Hey, very good morning, students. Let us look into the design of shift registers. Before getting into it, let us see what is a register. Register is nothing but group of flip-flops. Group of flip-flops is called as a register. So, what is the job of a flip-flop? Flip-flop is used to store one bit data. Okay. If I want to store more than one bit, then I have to make use of more number of flip-flops. Suppose I take four flip-flops, it means I can store 4 bits of information. If I group two flip-flops, I can use to store 2 bits of information. So what is a register? Register is nothing but group of flip-flops or bundle of flip-flops. Group of flip-flops bundled together is called as register. If I group 4 flip-flops, I call it as 4-bit register. Can you see I have grouped 4 flip-flops here. What type of flip-flop? D flip-flop. So D0, D1, D2, D3 are inputs. Q0, Q1, Q2, Q3 are outputs. Common clock is given to 4 flip-flops. This is an example of 4-bit register. Now, how am I going to feed the data? I can feed it serially or parallelly. What is serially? If I feed data bit, if I store data in a flip-flop one at a time, then I call it as serial. If I store data, all the data at the same time, all bits at the same time, then I call it as parallel. You know what is serial loading? What is serial loading? Store the data one at a time, one bit at a time. Then it is called serial. What is parallel? Load the data parallelly, all bits. Suppose it is a, can you see this example? It's a 4-bit register. 1, 2, 3, 4. It's a 4-bit register. Load 4 bits at a time. I call it as parallel. We can store all bits at a time. So based on this, we can classify a register. So based on the input and output, we can classify a register as serial in, serial out. What do you mean by that? Serially feed the data and get the data serially out. Serial in, serial out. That is called as SISO. What is next one? Serial in, parallel out. Serially feed the data, parallelly get the output. It is called serial in, parallel out. Bit by bit, you transfer the data into the register. Parallelly, at a time, you get the output. That is serial in, parallel out. What is parallel in? Parallelly load the data and get it output serially. So parallel in, serial out. What is parallel in, parallel out? Load the data parallelly, read the data parallelly out. Feed it parallelly as an input, read it parallelly as an output. So the first 3 types of registers are also called as shift registers. You can classify a register based on the applications. If I shift the bits inside the register, see, if I want the data to come from serial into serial out, the bits will be shifted from one position to other position to come outside. So if the bits are internally shifted, you call it a shift registers. So serial in, serial out is a shift register. Serial in, parallel out. What is serial in? Serially you store the bit one by one. So this is also an example of shift register. Parallel and serial out. Though parallelly we load the data, but I move the data, I shift the data one by one to come as a outside. So it's 1, 2, 3 acts as a shift register, whereas the fourth one acts like a storage register. Parallelly I load the data and parallelly I read it. So the data will not be shifted. So I call this as a storage register. So let us see an example how to design a serial in, serial out. This is a circuit for serial in, serial out. This is a block diagram. I am going to design serial in, serial out register. So I have serial input, serial output, right? And this is a clock because all the flip-flops need common clock. Now let me take an example. I'm going to transfer how many bits? 1, 0, 1, 1. I'm going to design a shift register which is going to shift how many bits? 1, 0, 1, 1. 4 bits. Since there are 4 bits, I've taken 4 flip-flops. 1, 2, 3, 4. Since it is serial in, serial out, can you see serially I'm going to feed the input and serially I'm going to read the outputs. What is data in? Data is fed serially here. What is data out? Data is read serially as an output here. So since there are 4 bits, I use 4 flip-flops. 1, 2, 3, 4. How am I going to do the connection? Output of one flip-flop will be the input of other. Output of one flip-flop will be the input of other. Output of one will be the input of other. So I have given input D in. I have given output D out. This is serial in. This is serial out. How I am doing the connection? Output of one is given as the input of other. Output of one given as the input of other. Output of one given as the input of other. And a common clock is supplied to all the flip-flops. Now let us see the construction. Don't get worried about this diagram. Just only one logic. Initially, imagine all the outputs Q2, Q3, Q1, Q0 are zeros. Initially, all the outputs are zeros. Done? Now, what is that we are going to do? We are going to move the data, shift the data 1011 into the, we are going to load the data into the register. How am I going to do it? First instant of time, only 1 point formula. Listen carefully. First data at first clock period. Can you see this clock period? So what is my point? Initially, what will be the value? All the outputs Q3, Q2, Q1, Q0 will be what? Zeros. Done? This is assumption. Initially, all are zeros. Then at the first clock pulse, what is going to happen? First bit 1 will get into the D flip-flop. What is D flip-flop? Direct flip-flop. Whatever comes as the input of D, that will go as the output. So if 1 is coming in D3, Q3 will also be 1. Okay. So can you see at the first clock pulse, 1 is coming in D3. What is Q3? Q3 will be 1, direct flip-flop. Whatever fed as the input will come as the output. So Q3 is 1. Now see how it is constructed. Q3 is connected to second Q2, D2. Q2 is connected to D1. Q1 is connected to D0. It means Q3 output will go to Q2. Previously what was Q3? 0. That will go to Q2. Q2 will go to Q1. What is Q2? 0. That will go to Q1. Q1 will go to Q0. Q1, whatever value you have, will go to Q0. We are done. Okay. Whatever you had in Q1 will come out. Okay. Now in the second clock pulse, what happens? Can you see? In second clock pulse, second bit will enter into D3. What is second bit? 1 will enter here. That 1 will come out as a Q3. Okay. Now Q3 will go to Q2. Q3, whatever previous value is there, will go to Q2. Q2 will go to Q1. Q2 will go to Q1. Can you see? Q1 will go to Q0. Okay, Q1 will go to Q0. Whatever Q0 value here will come out. The third clock pulse. Can you see? Third clock pulse. What value will come to D3? 0 will come to D3. So Q3 is 0. Then what happens? Tell me now. Q3 will go to Q2. So whatever previous value you have in Q3 will go to Q2. Q2 will go to Q1. Q1 will go to Q0. The fourth clock pulse, 0, first clock pulse, second clock pulse, third clock pulse, fourth clock pulse, 1 will come to D3. Q3 will be 1. Okay. Then what is the next step? Q3 will go to Q2. Q2 will go to Q1. Q1 will go to Q0. This is how the bits keeps on shifting. So how many clock pulses it needs to load all 4 flip-flops? It needs 4 clock pulses to load all the 4 flip-flops. Clear? This is given as a signal graph here. See the graph clock. So it is sequence of pulses of clock pulses. Now what is Q3? 1, 0, 1, 1, 0, 1. 0, 1, 1, 0, 1. What is Q2? 0, 0, 1, 1, 0. 0, 0, 1, 1, 0. What is Q3? 0, 0, 1, 1. 0, 0, 0, 1, 1. 0, 0, 1, 1. What is Q0? 4 zeros, 1. 4 zeros and 1. Can you see? This is 0, 0, 0, 0. Initial condition. Okay. So this is how the data is shifted. When you get the full data 1011 outside, when you get a full data 1011 outside, you get only after 1, 2, 3, 4, 4 clock pulses. 1, 2, 3, 4. Only after 4 clock pulses, you get 1011 as inside each flip-flop. So this is called serial in, serial out. Okay, now let us see the next one, serial in, parallel out. What is serial in? All the data is sent bit by bit. What is parallel out? But what is the difference between serial in, serial out? What is serial in, serial out? Serial in, serial out. What is serial in, parallel out? Serial in, but instead of getting data serial out, at every output I take my data as outside. Okay, so this is serial in, parallel out. Okay, can you see Q0, Q1, Q2, Q3 parallelly coming out? This is serial in, parallel out. This is an example of 4-bit serial in, parallel out. 4 bits. So I am using 4 flip-flops. Otherwise, construction is same. Output of one is input of other. Output of one is input of other. Output of one flip-flop is input of other flip-flop. But output I have not taken here. I have taken at every single output place. Okay, so this is serial in, parallel. See the diagram? I want to transfer 1011. Clear? So what happens? You know this. I want to transfer 1011. Similar, same thing. Just couple of minutes back. Initially considered as all 0. Now transfer the first bit. Then transfer, shift the bits. Then transfer second bit 1 1. Then shift the bits. Then transfer 0 1 1 0 1 1 and shift the bits. Finally 1 0 1 1. After 4 clock pulses, see there is no change in the working of serial in, serial out and serial in, parallel out. The only difference is there we get the output only at this point. Here we get output instantly at every single flip-flop outputs. Okay, so that is the difference. So this is about serial in, serial out, serial in, parallel out. What is the advantage? Next one is parallel in, parallel out. So parallel in, parallel out is parallelly we are loading the data. Can you see the flip-flop? I want to load 4 bits. So I am taking 4 flip-flops, D3, D2, D1, D0. Here input, can you see D3 is given here, D2 is given here, D1 is given here, D0 is given here. Outputs are Q3, Q1, Q2 and Q0. So common clock is connected. So what happens if I feed 4 bits as the input, 1, 1, 0, 1, all that 4 bits will get into the flip-flop, come as the output, Q3, Q1, Q0, Q1. So there is no shift of data. There is no shift of data from one flip-flop to other flip-flop. Can you see there is no, in previously we have seen Q3 is connected to D2, Q2 is connected to D1, Q1 is connected to D0. Output of one flip-flop is connected to the input of other. Whereas here, there is no connection. So whatever you give as an input will come as an output. That is why we will not call it as a shift register. We call this as a storage register. Whatever you feed, it will come as an output. Or that is the reason we call it a storage register or buffer register. See the diagram here, 1101 is fed as an input. That will come output as 1101. So your D3, Q0, Q1, Q2, Q3, your outputs will be equal to your inputs. Clear? So this is how, this is a short video about construction of serial in, serial out, serial in, parallel out, parallel in, parallel out shift register. Thank you.